Hi everyone. Today we are going to discuss about the topic of index properties of soil and its classification. This topic forms a base for understanding soil behavior and is extremely important for both practical civil engineering applications and which also used for competitive examination such as a gate RRP. Okay. Before any structure is designed, whether it is a building or highway or embankment or foundation, the engineer must first understand the nature of the soil. That understanding begins with the index property. So let us start. These are all the list of content we are going to discuss in the classes. Index properties and coarse grain soil behavior of index properties, and then fine grained soil behavior, after that soil classification, and then concluded with importance of system of soil classifications. Here the first one is, this presentation mainly focus on understanding the basic properties of soil that help us predict its behavior. Index properties do not directly give the design value, but they help us classify soil and estimate its strength and compressibility and suitable for construction. Okay, this topic one of the most vital area in the soil mechanics. After that, index properties of soil. Here, total various engineer understand how the soil behaves under different condition. These properties include grain size, Atterbuck limit, specific gravity, and relative density. By studying these properties, we can predict how the soil will react to moisture changes, loading, and compaction. And also, here index properties form the various earthwork design foundation. Okay, after that safety check and pavement evaluations. Without a clear understanding of these properties, a construction may become unsafe or uneconomical. Therefore, index properties play a crucial role in reliable construction practices. Okay, here these are all the main thing in strength, load bearing capacity, swelling and shrinkage, and settlement. These are all the various properties included in the index. Okay, here this one is a index properties of soil may be related to individual soil grain. Okay, and also aggregate soil mass. Here index properties can be related to individual soil grain or to the soil mass as a whole. Grain properties depend on the particle size, shape, and mineral composition and can be determined from distributed sample. Main thing, aggregate soil mass properties depend on soil formation and structures and are preferably determined from undistributed sample. Here two columns are there. The first column is represent the types of soil and then second column is the index. Here coarse soil have grain shape, grain size, relative density, and also fine soil mean we need to identify Atterbuck limit and consistency of the soil. Okay, the first one is a coarse grain soil. Here coarse grain soil such as sand and gravel have bulk grains that may be angular or rounded. Angular particle provide higher shear strength due to the better interlocking, while rounded particle provide lower strength. Specifically describe how close a particle shape is to be sphere. Here the formula is dE divided by L. Here dE is a diameter of equivalent spherical particle and then L is a length of the particle. Here dE 6V divided by pi power of 1 by 3 we used for determining the coarse grain soil. Okay, after that grain size analysis is carried out using sieve analysis. Here these are all the sieve analysis sizes, coarse sieve analysis and fine sieve analysis. Coarse sieve analysis, that is 80, 20, 10 and 4.75 used. After that, fine sieve analysis mean 2 1 600 micron, 425 micron, 212 micron, 150 micron and 75 micron were used in the fine sieve analysis. After that, relative density. Here relative density is used to express the compactness of coarse grained soil. It is equivalent to consistency in clayey soil, and also relatively density help us understand the whether the soil is a loose or medium dense or tense condition. Okay, here these are all the formulas to determine their relative density. E maximum, okay, equal to E maximum minus E minimum. Here E maximum mean void ratio of coarse grained soil in its loosest state. E minimum mean void ratio of coarse grained soil in its tensest state. Here E is represent the void ratio of coarse grained soil in its existing natural state in the field. Here two columns are represented in the table. In the table, one column is density index or relative density. After that, second one is a classification. Here relative density comes under the 0 to 15 mean it is very loose soil, 15 to 35 means loose soil, 35 to 65 means medium dense, 65 to 85 mean dense, 85 to 100 value will occur mean it is very dense. Okay. After that, the consistency. Here consistency refer to the resistance of soil to the deformation. This property is mainly used for clayey soil and depend on water content. As water content increases, soil behavior change significantly. Okay. Here this one is a figure for fine grained soil. X-axis represent the water content. If the water content increases mean liquid state will form. Y-axis represent the volume. Okay, here water content increases mean liquid level volume gradually increases, solid state gradually decreases. Okay, here shrinkage limit, plastic limit and liquid limit, three cases will occur based on the water content. If water content is less means shrinkage limit occur. After that, plastic limit occur. Over more than water content means liquid limit is occur. Okay. After that, Atterberg limit is a soil exists in four states here: solid, semi-solid, plastic and liquid. Each state represent in a different behavior of soil. Okay, here liquid limit is minimum water content at which soil start to flow. At this stage, soil have very low shear strength. Liquid limit is one of the most important index properties used in the soil classification. After that, plastic limit. Here plastic limit is a minimum water content at which the soil remains plastic. At this limit, soil start crumpling when rolled into the 3 mm diameter threaded. This test indicate the workability of clay. Followed by shrinkage limit. Here shrinkage limit is a maximum water content below which further reduction in water content does not causes volume reduction, main thing. Okay, below this limit air entered in the voids and cracking may occur in the clayey soil. Okay, next topic is a soil classification. Here soil classification involves grouping of soil with similar behavior. It simplifies engineering decision but does not replace detailed laboratory testing. The important system of soil classification means unified soil classification system. It is also called as a USCS. The USCS classifies soil based on grain size distribution and plasticity. It divided soil into coarse grain, fine grain and organic soil and is widely used in geotechnical engineering part. After that, Indian standard soil classification system. Here Indian standard soil classification system is similar to USCS but further divides fine grained soil into low, medium and high compressibility groups. This system is suitable for Indian soil condition. After that, AASHTO soil classification system. Here, ASTO system is mainly used in highway engineering. Soil are classified into group A1 to A7 based on the grain size and plasticity. This group index indicates the quality of soil as a subgrade material. Okay, here the group index is equal to 0.2a plus 0.005 AC plus 0.001 BD. Here A represent the portion of the percentage of the soil particle passing the 75 micron, that is greater than 35 but not greater than 75. Understand? After that, B equal to the proportion of the percentage of the soil particle passing the 75 micron, that is greater than 15 but not greater than 55 is a condition. Here C is a proportion of the liquid limit, that is greater than 40 but less than 60. And finally D is represent the portion of the plasticity index greater than 10 but less than 30. Okay, here these are all the condition for the ASO soil classification system. Finally, the importance of index properties of soil in engineering. Here, index properties help engineer decided whether the soil is suitable for foundation, road, embankment or drainage works. They guide decision on soil replacement, stabilization and foundation type. Okay. After that, to conclude, index properties of soil form the backbone of the soil mechanics. A clear understanding of these properties help in the safe, economical and durable construction. I hope this session has helped you to understanding the importance of index properties and soil classification. Thank you. Thank you for watching.